Hello friends, welcome to VK lectures. In this lecture, we are discussing the vector calculus topic from mathematical methods of physics. We'll be discussing about the gradient, divergent and curl. This gradient of a scalar. The gradient of a scalar gives you a vector quantity. Now in any dimension you can write the gradient of a scalar del phi. Phi is the scalar and del is the operator, is given by q1 cap by h1 into dou by dou q1 plus q2 cap by h2 dou by dou q2 plus q3 cap by h3 dou by dou q3 into phi. So this gives us the gradient of the scalar, and this qi, that is q1, q2, q3 are the axis or the direction or unit vectors in the corresponding coordinate system. For example, qi can be q1, q2, q3, that's equal to x cap, y cap, z cap. This is in Cartesian coordinate system, three-dimensional Cartesian coordinate system. And for spherical, polar and cylindrical coordinate system, you will have their own unit vectors. Now, and what are this h? Hi is the metric element corresponding to each direction, So this h1 will vary in a different coordinate system also. Now for three-dimensional Cartesian coordinate system, the del phi can be written as the q1 cap is x cap dou by dou x, and h1, what is the value of h1? h1 is equal to 1, h2 equal to 1, h3 equal to 1. This is for Cartesian coordinate system. So x cap dou by dou x of phi plus y cap dou by dou y of phi plus z cap dou by dou z of phi. So this is the x coordinate, y coordinate and z coordinate. Now for example, if phi is equal to x, y, z, phi equal to x, y, z, find del phi, which is equal to x cap into dou by dou x of x, y, z plus y cap into dou by dou x of, dou by dou y of x, y, z plus z cap into dou by dou z of x, y, z. Now this is partial derivative. So dou by dou x of xyz means yz. So x cap into yz plus z cap into, this is y, so xz plus z cap into here xy. This is the direction, x cap z, this is y cap, or you can also write like this, I cap. So yz I plus xz j plus xy k, but it is better you follow some standard xy z. Alright, now we have the phi is a scalar quantity. See, you do not have any direction to it. X, y, z is a scalar quantity. Now del phi, what we are getting, this is a vector. Now sometimes in the question it will be del phi at 1 minus 1 1. So you have to substitute for, this is x, y and z. So substitute for x, y, z, you will get the corresponding vectors. So in this case this is y and z, so minus 1 I cap, so minus I cap, plus xz, that is minus I, plus j cap, plus xy, that is again minus 1, minus k cap. So this will be the how you will be getting. So let us write this as vector A. So vector A is of this form, and more importantly, sometimes you may have to divide by the normalizing or divide by the magnitude of the vector. Normalizing means the quantum mechanical idea. Okay. So from this it is understood that it is a cylindrical coordinate system, and what is the values of h1 is equal to 1 and h2 equal to rho and h3 equal to 1, and the directions are rho, phi, z. So what we can write, del phi is equal to rho cap into dou by dou rho of rho z square cos phi. So this is the first term, plus phi cap into phi cap by h2, phi cap by rho, dou by dou rho, dou by dou phi, dou by dou phi of rho z square cos phi plus the rho phi and z cap by, here this is 1, this is z cap by 1, dou by dou rho phi z of rho z square cos phi. So let us write down each terms. This would be equal to rho cap into dou by dou rho, so rho will go z square cos phi, this is phi cap by rho into, with respect to phi you can write rho z square cos phi differentiation minus sin phi, here is equal to z cap into dou by dou z. So 2 rho z cos phi. Now you can write this in general. So z square cos phi rho cap plus this 1 by rho and 1 by rho, this one and this one gets cancelled, z square, so minus z square sin phi minus z square sin phi. What is the direction? Phi cap plus 2 rho z cos phi z cap, 2 rho z cos phi z cap. So find the del phi at 1 minus 1 pi. That is your work. So 2r square sin theta cos phi. So this is r theta phi. So r theta phi, this corresponds to spherical polar coordinates. Okay, now what we have to do, first we have to find the corresponding h1, h2, h3. h1 is 1, h2 is r, and h3 is r sin theta. And what are q1 cap, q2 cap and q3 cap? q1 cap is r cap, this is theta cap, this is phi cap, r theta phi. So what is del phi now? Del phi is equal to q1 cap by h1 dou by dou q1 plus q2 cap by h2 dou by dou q2 plus q3 cap by h3 dou by dou q3. This is phi, sorry, this is not vector phi. Let us take this as some alpha, some alpha. So alpha. I just don't want to take phi again. Phi is, we have already taken phi. This is, let it be del alpha. Okay. So now what you can say, q1 cap, that is q1, that is r cap dou by dou r of 2r square sin theta cos phi. Then q2 cap, that is r cap theta cap by h2, what is h2? R, dou by dou r theta into 2r square sin theta cos phi. Then h3 q3, that is phi cap by r sin theta dou by dou phi, 2r square sin theta cos phi. So this gives us r cap into dou by dou r of this quantity, that is 2r square. 2r square means 4r's. 4r sin theta cos phi. This is equal to theta cap by r dou by dou theta. So sin theta will become cos theta. So 2r square sin theta cos theta cos phi. This is equal to phi cap. So phi cap by r sin theta. With respect to phi, so cos phi will become minus. So minus 2r square sin theta sin phi. Now this is what you have. Now this you have to divide. So that is 4r sin theta cos phi r cap plus this r and r get cancelled. 2r cos theta cos phi theta cap plus this one r sin theta will get cancelled. So 2r sin phi minus 2r sin phi cap. You can find del alpha at minus 1 pi by 2. That is your work. Here are few questions that you can try. The potential or the V, that is the scalar field, is given. You have to find out the gradient of the scalar field. Divergence of a vector. So how much divergence is there for a vector quantity? Okay, that's given by del dot a, some any vector a. So this gives us a scalar quantity. So from we have a vector quantity, and when you do the divergence you will arrive at a scalar quantity. Now for a general coordinate system, system, we have the q1, q2, q3 as the unit vectors, and the metric elements are h1, h2 and h3. Now how can you write for a general coordinate system the divergence? It can be written as for any vector a can be written as a1, that is the corresponding to the q1, a1 q1 cap plus a2 q2 cap plus a3 q3 cap. This is the quantity, the value of each quantity in each direction, q1, q2 and q3. Then you can write del dot a, that's equal to 1 divided by h1, h2, h3, then the bracket dou by dou q1 into a1 times h2 h3, a1 times h2 h3 plus dou by dou q2 a2 times h3 h1 plus dou by dou q3 a3 h1 h2. Please remember it in this order so that you will not confuse. So Now let us see for the first question number 1 for Cartesian coordinate system. Uh, Vector A is given as ax into x cap plus ay into y cap plus az into z cap. Now find del dot A at 1 1 1. So for Cartesian coordinate system, this is Cartesian coordinate system. By looking at the unit vector, I can understand that it is from the vector is in a Cartesian coordinate system. So let us start with 1 by h1 h2 h3. So for Cartesian coordinate system, h1 equal to 1, h2 equal to 1, h3 equal to 1. So this terms is 1. Now dou by dou q1 of dou q1 means dou by dou x of ax. A1 is ax, so ax plus dou by, because h2 and h3 are all equal to 1, so dou by dou y of a2, that is ay, plus dou by dou z of az. Now here we do not have any terms corresponding to divide it, to differentiate. So what we will do, this will remain as ax ay, so we could have gone with some other ax. Let us write ax equal to x square. Let us take some values. Ax equal to x square, ay equal to some 2y, and az is equal to z. So dou by dou x of x square is 2x plus ay is equal to 2y, so that is 2 plus az equal to z, so that is 1. So 2x, so x value is 1, so that gives 2 plus 1, that's equal to 5. So this is here we have a question that is the vector A is equal to yz x cap plus xz y cap plus xy z cap. The question is to find del dot A, the divergent of A, that's equal to dou by dou x of ax, the coefficient of the x cap, then dou by dou y of ay, this is ay, the coefficient of y cap, and dou by dou z of az, which is the coefficient of x z cap. Now dou by dou x of yz, dou by dou y of xz, and dou by dou z of xy. So the first term does not contain x, the second term does not contain y, and third term does not contain z. So the partial derivative gives 0. So del dot A is 0. Now here is a second question. The first question is from three-dimensional Cartesian coordinate system, and second one you have rho, phi and z. So this is a cylindrical coordinate system, and you need to find del dot A at 1 pi by 2 minus 1. So this is the question. Please find the answer. Vector A is given to be rho sine phi rho cap plus rho square z phi plus z cos phi z cap. Now what we have to find? Del dot A. So del dot A is equal to, in general, what is that? 1 by h1 h2 h3 dou by dou q1 of a1 h2 h3 plus dou by dou q2 a2 h1 h3 plus dou by dou q3 a3 h1 h2. Now for cylindrical coordinate system, h1 equal to 1, h2 equal to rho, h3 equal to 1. So that's equal to 1 by rho dou by dou rho a1, that is this one, a1 rho sine phi into rho sine phi into h2 h3. What is h2 into rho? So into rho plus dou by dou q2. What is q2? Phi. A2 is rho square z into h1 h3. h1 and h3 are same, plus dou by dou rho phi and z. A3 is z cos phi. h1 h2, 1 rho will be there. So that's equal to 1 by rho. This is rho square. So 2 rho sine phi plus this term will go, this node, plus dou by dou z. So rho cos phi. So 1 by rho into this quantity. So here 1 rho is there, 1 rho. So 2 sine phi plus cos phi. Now what is the value of phi? Phi is equal to pi. So 2 sine pi, that is 0, cos pi is minus 1. The vector A is given as 1 by r square sine theta r cap, r sine theta cos phi theta cap, cos theta phi cap. Now question is to find the divergent del dot A at minus 1 pi by 4 pi by 4. Application of gradient. What I mean by gradient? Gradient is del phi. Del phi, or sometimes it is represented as gradient phi. Now this gradient of phi is a vector quantity, and this vector has a nature, that is, it is perpendicular to the surface, perpendicular or norm. It is a normal vector. Normal means perpendicular. Perpendicular vector to the surface. Which surface? Where the phi is. Direction is perpendicular to the phi surface. Okay. Now, since it is a vector, you can get the magnitude. The magnitude of del phi is equal to normal, just the norm vector. How do you find the magnitude? Root of ax square plus ay square plus az square. This is how you find the magnitude. And what about the this is the magnitude. Now, how to find the direction? Direction or unit normal. The direction is nothing but unit vector. Unit vector has unit magnitude, that is why it is called unit vector. So it gives only the direction, no magnitude. So unit normal, that is given by the gradient of phi divided by the magnitude of the grade phi. Now, suppose if this gradient of phi gives you the vector A, vector A by magnitude of vector A is the unit vector. Unit vector in the direction of A. Let us call this by n cap. Okay, so let us once again write in grade phi by magnitude of grade phi equal to, so instead of A I am writing the normal vector n and its magnitude by magnitude of n is equal to n cap. So n cap, small letter n cap is the unit vector, capital N is, n vector is normal vector. Now, what does it tells you? Grade phi. Gradient of phi means it tells you how fast a function increases or decreases, with respect to time or space, but usually it is space gradient. With respect to time, we mention it as rate of change of momentum, but with respect to gradient, it is with respect to space only. Okay, the gradient is with respect to space. With respect to time, we say it as not as gradient, but yeah, gradient with respect to time. This is with respect to space. Now you got how fast a function increases or decreases. Now, what about the that is given by the vector n, the normal vector, or what you say, let us write the magnitude. So magnitude tells us how fast. Okay, now what does this n represent? N is, we know, gradient of phi, and this tells us in which direction function increases or decreases. The magnitude tells us how fast. The quantity, the vector n or n cap, that is equal to vector n by magnitude of n. This tells us the direction, in which direction the function is increasing rapidly, increases rapidly. See, there may be many points or directions where the function is increasing, but there will be some particular direction in which function increases rapidly. Okay, one good example of this application is the electric field. Electric field E is equal to minus del V. The electric field is gradient of the potential. Here are few questions. All questions are related to finding the unit normal for the function at different points. Answers to the previous questions are also given here. You can verify it after doing. Phi is equal to xyz. So since it is in Cartesian coordinate system, you can write x cap into dou by dou x of xyz plus y cap into dou by dou x dou y of xyz plus z cap into dou by dou z of xyz. Yeah. Now x cap into dou by dou x, so x cap into yz plus y cap into y xz plus z cap into z xy. Now at what is the point? 1 1 1 1 1 minus 1, is it? Application of gradient. The application is finding the angle between two surfaces. Finding angle between two surfaces or surfaces. Okay. Now assume that this is one surface and this is another surface. Now this is the perpendicular direction, that means the del phi, and this is the another, this is surface 1, this is surface 2. So if I want to find out the angle between these two surfaces, how this surface is aligned, I have to find the normal vector n1 cap. here I had to find the normal vector n2 cap. The angle between the surface is equal to angle between the perpendicular vectors of each, or normal vector to each. So instead of finding the angle between the surface, or it is better to find the angle between their normals. Okay, so n1 cap is equal to del phi 1, let phi 1 be the surface 1, by magnitude of del phi 1, and n2 cap is equal to del phi 2 by the magnitude of del phi 2. So n1 cap and n2 cap is ready. So you need to find out the angle between them. Now how is the angle between them? Now let us find out what is n1 cap dot n2 cap. That will be equal to magnitude of n1 cap into magnitude of n2 cap divided into n1 n2 cos theta. The angle between theta is the angle between them. So theta is okay, angle between phi 1 and phi 2. Now what is this cos theta? Cos theta is equal to magnitude of n1 n1 cap dot n2 cap divided by magnitude of n1 cap into magnitude of n2 cap. Now n1 is a normal vector, unit vector. Unit vector magnitude will be equal to 1. So cos theta is equal to n1 cap dot n2 cap. So this is cos theta. From this we can find theta is equal to cos inverse of n1 cap dot n2 cap. Find the angle between two surfaces at 2, 1, minus 2. The two surfaces are phi 1 equal to x square plus y square plus z square, phi 2 equal to x square plus y square minus z. So del phi 1 dou by dou x of phi 1, that is equal to 2x into x cap plus 2y into y cap plus 2z into z cap. Now we need to find del phi 1 at 2, 1, minus 2. So that's equal to, put x equal to 2, y equal to 1 and z equal to minus 2. So 4x cap plus 2y cap minus 4z cap. So that becomes del phi, and what is n cap? Del phi 1, n1 cap equal to del phi 1 by magnitude of del phi 1. So that's equal to 4x cap plus 2y cap minus 4z cap divided by root of 16 plus 4 plus 16. So that is 36. So that is root 6. So let it be root 36 itself, or you can write root 6. Sorry, 6. So 4x cap plus 2y cap minus 4z by 6. Let it be. Now coming to the second one, del phi 2 equal to 2x into x cap plus 2y into y cap minus 1 z cap. Del phi 2 at 2 1 minus 2 is equal to 4x cap plus 2y cap minus z cap. N2 cap, that is del phi 2 by magnitude of del phi 2, that's equal to 4x cap plus 2y cap minus z cap divided by 416 plus 4 plus 1 root 21. Okay, so that is n2 cap. So 4x cap plus 2y cap minus z cap divided by root 21. Now theta is equal to n1 cap dot n2 cap. So that's equal to 4x into 4x, that is 16 plus 2y into y plus 4 into 4, that is minus, wait, yeah, plus 4 divided by root 6 root 21. So that's equal to 24 divided by 6 root 21, that's equal to 4. So 4 divided by root 21, that is equal to, that is cos theta. So theta will be equal to cos inverse 4 by root 21. So it's almost equal to 1, so theta will be around 0, because root of 25 is 5, root of 16 is 4, so between 16 and 25. Question for practice. Two functions are given, two surface phi 1 and phi 2. The question is to find the angle between them at 2 2 minus 2. Application of the gradient. Next application, that is the directional derivative. Now what is this directional derivative? Now we know for any general surface, let us say if this is the normal vector n, and corresponding to that we have n cap, which is equal to del phi by magnitude of del phi, or vector n divided by magnitude of vector n, normal vector. Now this is the direction in which the function changes rapidly. That is what the normal vector means. Now the question is, and this is the direction where maximum changes occurs, maximum increase or decrease in a function is in this particular direction. Now, but I don't want the maximum direction or maximum increase or decrease. I want in a certain direction what is the change, how fast the directional derivative, the idea is how fast the function phi changes along a particular direction. Now n vector says maximum change occurs in this direction, but we don't know in other certain direction. For example, I have a vector A. I need to find how the function changes along this vector A. So what we will do? So A, we can write it as the A cap, the direction A cap is equal to magnitude of vector A by the magnitude of the vector A. Right. Now to find the directional derivative, the formula is directional derivative, let us give the name D, is equal to del phi, that is the vector n, dot A cap, that's equal to del phi A cos theta. Now what is this theta? Theta is angle between del phi and A. So what is del phi? Del phi is n vector, A is this particular vector. So this is the angle between them, theta. So along the direction A, what is the change? The directional derivative is phi A cos theta. Remember, A is a unit vector. So you can write the directional derivative as the rate of change of function in an arbitrary direction. In any direction, that is the meaning. So that is projection means dot product, projection of del phi on arbitrary direction. So this is the directional derivative. Find the rate of change of the function phi equal to x square y plus yz at 1, 1, minus 1 in the direction of I plus 2j plus 3k. Application of gradient, equation of tangent plane to the surface. Now what does this mean? If we have a surface, we know this is where the some place, it can be anywhere. Assume that this is where it is the normal and it is in this direction where the function increases maximum. Then I need to draw a surface such that it is tangent to the surface, a plane which is tangent to the surface, something like this. So this looks like a plane which is kept over the surface. Okay, that equation we are looking at. Okay, so just the basic understanding of what it is about. If this is the surface and here we have the tangent plane. Tangent plane means perpendicular. This is what is tangent plane means. So now what is the idea is, if there is a vector lying in the tangent plane, suppose suppose if there is a vector like this which is some r, okay, then r dot vector n will be equal to 0, right? So anywhere on this plane, if r dot n is equal to 0, means any line or any vector in this plane will give us r dot n equal to 0. So that is our required plane. So what we need, first of all we need del phi, which is the normal to the surface, which is given by del phi, and that is the vector n. Now assume that this is some point at the center, and there is a point on the surface, the tangent plane, and it is the point on the plane. Okay, now if I connect these two vectors or these 2 points, if this is r0 and this is r, that means this is an r0 which is given point, this is r, any arbitrary point. So the line between these two, for example this is A, B and C, then BC is given by r minus r0, because r0 is this vector and r is this vector, so in the opposite direction it is moving. Okay, so what is this distance? This distance, which is BC, given by r minus r0. So what is r minus r0? R minus r0 is a vector in the plane, in the tangent plane. Now this r minus r0, which is a vector, when you make it dot product with n, should give us 0. So this is a tangent plane. This is the surface phi. So here, which means that n vector n is perpendicular to r minus r naught. So since they are perpendicular, you can do multiple dot product and you get it 0. So in general, if this given point is x naught, y naught and z naught, and arbitrary point is x, y, z, then x minus x naught plus y minus y naught plus x minus x naught into I cap plus y minus y naught into j cap plus z minus z naught into k cap dot the normal vector is del phi. Del phi is equal to 0. Through this you can get the equation of tangent plane. This is the equation for tangent plane. Find the equation of tangent plane to the surface. The surface is given as phi is equal to x square y z cube at 1 1 minus 1. So let's find del phi first. Del phi is equal to, with respect to x, 2xyz cube, 2xyz cube x cap plus x square z cube y cap plus 3x square yz square. Now del phi at 1 1 minus 1 is equal to 2 times x is 1, y is 1, z, so 2 times minus 1 x cap plus 1 and minus 1 minus 1 y cap plus 3x, so 3, this is z cap. So that's equal to minus 2x cap minus y cap plus 3z cap. Okay, now that's about del phi. Now we need a vector a point x minus x naught. So r minus r naught is equal to x minus x naught I cap, oh sorry, let us write x cap plus y minus y naught y cap plus z minus z naught z cap. Now let this point be equal to x naught, y naught and z naught, because it is a point on the surface. So x naught, y naught, z naught be that point. So x minus x naught is 1, so x minus 1 x cap plus y minus 1 y cap plus z minus minus 1, that is z plus 1 z cap dot, sorry, let us write this one. So del phi dot r minus r naught is equal to minus 2 into x minus 1 plus minus 1 into y cap, that is y minus 1, plus 3 into z plus 1 equal to 0. So that's equal to minus 2 plus 2, sorry, minus 2x plus 2 minus y plus 1 plus 3z plus 3 equal to 0. Now bring this x terms together, so bring that to the other side. So 2x plus y minus 3z equal to 2 plus 1 3 plus 1 plus 3 6. So 2x plus y minus 3z equal to 6. Is it plus? Yeah. No, it's minus, right? Yeah. Laplacian operator, which is given by del square. Now for a general coordinate system, for any general coordinate system, del square is given by 1 by h1 h2 h3 into dou by dou q1 into h2 h3 by h1 into dou by dou q1 of dou by dou q1, yeah, whatever is, yeah, plus dou by dou q2 h3 h1 by h2 into dou by dou q2 plus dou by dou q3 h1 h2 by h3 times dou by dou q3. So this is del square operator. You can write del square for Cartesian, cylindrical and spherical polar. That's your work. Please continue doing. Curl of a vector. So curl of a vector is given by del cross A, where A is any vector, and this gives us another vector. Curl of a vector is another vector. Okay. Now for any A given by A1 Q1 cap plus A2 Q2 cap plus A3 Q3 cap. The del cross A, the curl of the vector A is given by 1 by h1 h2 h3, where h1 h2 h3 are the metric element. Its cross product, that is h1 q1 cap h2 q2 cap h3 q3 cap. Along with the unit vector, you must also mention its uh, metric element. Then dou by dou q1, dou by dou q2, dou by dou q3 of again h1 times a1, h2 times a2, h3 times a3. So for what you say, for Cartesian coordinate system, del cross A is given by 1 by h1, h2, h3, all h are metric element are equal to 1. So this is x cap, y cap, z cap, dou by dou x, dou by dou y, dou by dou z into ax, x component of A, y component of A, z component of A. So this will be like x cap into dou by dou y of az, dou by dou y of az minus dou by dou z of ay, dou by dou z of ay. Correct. This continues. Second term will be minus y cap into dou by dou x of az, sorry, yeah, dou by dou x of az minus dou by dou z of ax plus z cap into dou by dou x of ay minus dou by dou y of ax. So this is for the Cartesian coordinate system. So continuing with the curl for the cylindrical and spherical. For the cylindrical coordinate system, we have the function as let us write down the vector. A is equal to a rho into rho cap plus a phi into phi cap plus az into z cap, where rho cap, phi cap and z cap are the unit vectors and corresponding metric element is 1 rho 1. So h1 corresponds to 1, h2 is rho, and h3 is again 1. Now what is the formula? 1 by rho into, this is rho cap, and this is h1 times rho cap. So this is h1 into rho cap, that is 1 into rho cap, h2 into phi cap, that is h2 is rho into phi cap, then again 1 into z cap. Here it is dou by dou rho and dou by dou phi and dou by dou z. Now this is again 1 h1 into, so 1 into a rho, h2 is rho into a phi, then 1 into a z. So this can be written as rho cap into dou by dou phi of, so dou by dou phi of az minus dou by dou z of rho a phi. So you have to multiply a phi with rho, plus, or you can write minus rho into phi cap times dou by dou rho of az minus dou by dou z of a rho, plus z cap into dou by dou rho of a phi minus, dou by dou rho of rho a phi, dou rho of a phi minus dou by dou phi of a rho. So this is the curl of a vector. So this is del cross A in cylindrical coordinate system. So this entire thing you have to divide by 1 by rho also. So this entire thing times 1 by rho. Coming to the spherical polar coordinates. We can write del cross A equal to, before that let us write down what is A, and also let us write down what are the coordinates r, theta, phi. So A equal to AR into r cap plus A theta into theta cap plus A phi into phi cap. So AR into r cap, A theta into theta cap, A phi into phi cap. Now yes, so what are the metric element corresponding to r, theta and phi? Metric elements are 1, r sin theta. So the del cross A is 1 by h1, h2, h3, that is 1 by r square sin theta into r cap 1 into r cap, that is metric element 1 into r cap, r into theta cap, r sin theta into phi cap. Now this is dou by dou r, dou by dou theta, dou by dou phi, and here you have 1 into AR, here we have r into A theta and r sin theta into A phi. So the equation says 1 by r square sin theta into r cap into dou by dou theta of r sin theta a phi minus dou by dou phi of r times a theta. That's the first term. Then minus r theta cap into dou by dou r of r sin theta a phi minus dou by dou phi of ar plus r sin theta phi cap into dou by dou r of r times a theta minus dou by dou theta of ar. This is the del cross A in r theta phi, that is the spherical polar coordinates. Here are few questions for practice. Vector A in 3 different coordinate systems are given. You are asked to find del cross A, the curl of the vector A. So vector A is equal to rho sin phi rho cap plus rho square z phi cap plus z cos phi z cap. So this is in spherical polar coordinates. Sorry, this is in cylindrical. Cylindrical coordinate system. So since it is in cylindrical coordinate system, our del cross A will be 1 by h1, h2, h3. h1 is equal to 1, h2 equal to rho, h3 equal to again 1. So 1 by rho into h1 is 1, so rho cap, this is h2, rho into phi cap, then z cap, dou by dou rho, dou by dou phi, dou by dou z. This is a rho, a phi, a z. So 1 by rho outside. So this gives us rho cap into this one, dou by dou phi of az minus dou by dou z of a phi. This is within bracket. Sorry. Yeah. Plus minus rho phi cap into dou by dou rho of az minus dou by dou z of a rho plus z cap into dou by dou rho of a phi minus dou by dou phi of A rho. Okay, so that's equal to here 1 by rho is also there, so this is 1 by rho. Well, let us divide the entire thing into 1 by rho. So rho cap into dou by dou phi of AZ, dou by dou phi, what is AZ? AZ is this one, this is AZ, sorry, this is A rho, this is A phi, this is AZ, so Z cos phi minus dou by dou Z, dou by dou Z of A phi, what is A phi? Rho square Z, minus rho into phi cap to dou by dou rho of AZ. AZ is Z cos y minus dou by dou Z of A rho, is A rho, rho sin phi. Plus Z cap into dou by dou rho A phi, it is A phi, say phi, rho square Z, minus dou by dou phi of A rho, it is A rho, rho sin phi. So the first term, this everything into 1 by rho. So rho cap into dou by dou phi of Z cap. So Z minus Z sin phi minus rho square wait, oh, we have made a mistake. This is h1, so that is 1. Here you have to multiply by rho, here 1, h1 A rho, h1 q1 cap, sorry, this is h1 into a1, h2 into a2, h3 into a3. I hope you remember that. So wherever a phi is there, you have to multiply by rho, so this becomes cube. This is here a phi, here also cube. Now change further. Okay, so this is rho cube minus rho phi cap. This is dou by dou rho Z cos phi, no terms. Dou by dou Z rho sin phi, no terms. So this term, second term is 0, plus Z cap into dou by dou rho of rho cube Z, so 3 rho square Z phi minus cos phi, rho cos phi, rho cos phi into 1 by rho. So wherever there is rho, you can divide, but keep it as it is, 1 by rho, because here there is no term, here you have rho cube. Is this understood? The vector A is given to be 1 by r square sin theta r cap plus r sin theta cos phi theta cap plus cos phi phi cap cos phi phi cap. So now this is in spherical polar coordinates. Spherical polar coordinate system. So let us write down the formula for del cross A in general coordinate system. So 1 by h1 h2 h3 h1 q1 cap h2 q2 cap h3 q3 cap dou by dou q1 dou by dou q2 dou by dou q3 h1 a1 h2 a2 h3 a3. Here h1 is equal to 1, h2 equal to r, h3 equal to r sin theta. a1 is equal to sin theta by r square, a2 is equal to r sin theta cos phi, a3 equal to cos phi. Now let us write down what is del cross A in spherical polar coordinates. That's equal to h1 h2 h3, product of h1 h2 h3 is r square sin theta, so 1 by r square sin theta into h1 1, this is r cap, h2 is r theta then theta cap, h3 is r sin theta, q3 cap means phi cap, dou by dou r, dou by dou theta, dou by dou phi, ar h1 into a1, so h1 is 1, a1 is sin theta by r square, dou by dou theta and h2 is r times a2, a2 is r sin theta cos phi. Then you have the third component, h3 is r sin theta into a3 is cos phi. Let us write down here r cap into dou by dou theta of r sin theta cos phi minus dou by dou phi of r square sin theta cos phi. That's equal to r cap into dou by dou theta, so sin theta becomes cos theta, so r cos theta cos phi minus dou by dou phi. So cos phi become sin phi with a minus sign. So minus r square sin theta sin phi. R square sin theta sin phi. That is the first term. Now second term, r theta cap. R theta cap into dou by dou r of wait r theta cap. Oh, I think we made a mistake. No, fine. Dou by dou r of dou by dou theta. Theta cap. Okay, dou by dou r of r sin theta cos phi. Yeah, it's fine. R sin theta cos phi minus dou by dou phi of sin theta by r square. So that's equal to r theta cap into dou by dou r of r sin theta. So sin theta cos phi will remain. Sin theta cos phi minus this term will be 0. And there is a minus sign because this is the second term. Second term there is a minus sign. Then again last term, that is r sin theta phi cap into r sin theta phi cap into dou by dou r of r square sin theta cos phi. R square sin theta cos phi minus dou by dou theta of sin theta by r square. So what is remaining? R sin theta phi cap into dou by dou r of r square. So 2r sin theta cos phi. 2r sin theta cos phi minus dou by dou theta. So sin theta by r square, that will be equal to minus cos theta by r square. Now add these terms. This is the first term with respect to r cap. This is the theta cap, second term. Here you have the third term. Add all the term and divide by r square sin theta. It gives us the required answer. Radial forms for gradient, divergent and curl. So the radial forms. So radial forms, these are generally applied in the case of central force problems. So central force problems such as uh, gravitational field, electric field or electric force or gravitational force, then hydrogen atom problems, all these comes under the central force problems. So it is applied in central force where there is which can be represented in polar coordinates, which means it will have the radius as well as the poles. That means, for example, with respect to x, this line, so this is r and this is theta. So r theta is the polar coordinates, r and theta. So any central force problem can be represented by using the radius and theta, because the central force problem deals with the distance between, or they act along the center of two mass or two charges or 2-point particles. Okay, that is why they are called central force problems. Now as we have seen gradient for in general coordinate system, we are going to see for radial vectors or radial form how can we do that, which means why we need this. If our function phi is a function of r, if our phi is a function of r alone, only r, it is not a function of x, y, z, or in spherical polar coordinates we can also write phi as r theta phi, but theta and phi is constant. Okay, in such cases we can write phi as a function of r alone. So our gradient should be limited to finding the gradient of the function with respect to r alone. Okay, so in general coordinate system, we can write the del operator, which is or del operator is equal to q1 cap by h1 dou by dou q1 plus q2 cap by h2 dou by dou q2 plus q3 cap by h3 dou by dou q3. So this is the del operator in generalized coordinate system. And now we can say, since phi is a function of r alone, and let us also write down for phi for spherical polar coordinates. I am just writing here spherical. So this becomes r cap by dou by r cap by 1, because the metric element h1 is 1, dou by dou r plus q2 cap, q2 is phi cap, by h2 is r dou by dou, instead of theta, that is phi, plus r phi, so this is theta cap, and phi cap by r sin theta dou by dou, this is theta. Okay, this is dou by dou phi. Now since we will write del of just r, that means only function of r, so only the first term will remain, so that is r cap by dou r. So in the radial form, in radial form, the gradient can be written as phi of r is equal to, gradient of r equal to r cap dou by dou r. These two quantities will not be present because our function phi is a function of r alone. It's a function of only r, which means dou by dou theta and dou by dou phi of the phi, the scalar field phi, is 0. So these two terms will become 0. Only the first term, which is with respect to r, remains. Okay, so we can also write the gradient of phi of r is equal to r cap dou by dou r of phi of r. You need not do all these calculations. Now, in general, for any function, gradient of f of r, you can write r cap dou by dou r of f of r. Alright, now just a few functions let us take, usually found in numerical problems, that is del r power n. So this is the first one. So del r power n. So gradient of r power n, where r is a field. So that is r cap dou by dou r of r power n is equal to r cap dou by dou r of r power n is n r power n minus 1. Okay, now so first one. Now suppose if this is gradient of r, that's equal to r cap dou by dou r of r. Dou by dou r of r is 1, so that is r cap. So the gradient of the vector r is nothing but the unit vector in the direction of r. So third del r square, and that's equal to r cap dou by dou r of r square. You get r cap into 2r, that means you get 2 times the radius, 2r r cap. And similarly del r power minus 1, or that's equal to r cap dou by dou r of 1 by r. So that's equal to minus 1 by r square into r cap. So dou by dou r of 1 by r is 1 by r square in the direction of r cap. So minus 1 by r square r cap. Now fifth one, this is important. This is where most the time we find gradient of 1 by r square. So r cap dou by dou r of 1 by r square, that's equal to r cap 2 divided by r cube with the minus sign. So 2r cap by r cube. Now this is where 1 by r square, for example, the electric field, we write the electric field E is equal to 1 by 4 pi epsilon, or in air epsilon naught, q divided by r square. So we need the gradient of this electric field, or the related to the potential V is equal to 1 by 4 pi epsilon naught q divided by r, the electric potential. So E is equal to minus del V. So what you get? that's equal to minus del V 1 by 4 pi epsilon and Q. So 1 by 4 pi epsilon naught Q into gradient of 1 by R. So that's equal to minus 1 by R square. So what you are going to get is minus and minus, it will become plus. So 1 by 4 pi epsilon naught Q divided by R square. This is nothing but our electric field. This is our electric field. So that is what is the application where our vector or the function f of r is a function of r alone. When it is function of r alone, you can use the gradient in radial forms. And please kindly note that we cannot find the gradient of the electric field, because electric field is a vector quantity. So we can only find divergence or curl of electric field. Either we have to find del dot E, which is equal to the Gauss law in divergent form, and or del cross E. This is the two things that we can find. We cannot find del E because E is an electric field. Okay, so we are so this is not possible. Either we have to find del dot E or del cross E. Okay, so this is electric field in the direction of r cap. So this is a scalar field, which is V, that is the scalar potential, which is given by 1 by 4 pi epsilon naught Q by R, and here we can find the gradient of the potential, which gives us the electric field. Divergence in or of radial forms. Okay, so divergence of a vector, divergence in radial forms of a vector. So we take the divergence of a vector. So in general coordinate system, the divergence is given by, for any vector A, which is equal to A1 Q1 cap plus A2 Q2 cap plus A3 Q3 cap. So A is equal to A1 Q1 cap, A2 Q2 cap, and A3 Q3 cap, where A1, A2, A3 are the corresponding components. Okay, so for generalized coordinate system, we can write del dot A, or the divergence of the vector A is given by 1 divided by h1, h2, h3. So it's as follows: dou by dou q1 of A1, after A1 it is h2, h3, plus dou by dou q2, after q2 it is a3, sorry, it's a1, sorry, a2, h3, h1, plus dou by dou q3, a3, h1, h2. So this is the divergence, but we know only the first term will remain, because our gradient, or it is in radial form, is a function of r alone. That means A is a function of r alone. Then what you get is, in radial form, del dot A you can write, which is a function of r, is equal to, this term will remain constant, so that is 1 by r square sine theta into dou by dou r of the function f of r, and this term will remain. So h2, what is h1? h1 is 1, h2 is r, and h3 is r sine theta. So h2 h3 means r and r sine theta, so r square sine theta will remain. So dou by dou r of ar means the first term, a1, so ar into r square sine theta. So two terms, you have to differentiate the first term as well as the second term, UV differentiation. So since theta can be taken out, sine theta, which is independent of r, you can bring that outside. So this becomes 1 by r square dou by dou r of r square ar, and if you write ar is equal to some function of r, you can write the divergence of the vector a, or vector a can be written as f of r, because ar is f of r. So f of r into r cap is equal to 1 by r square dou by dou r of r square f of r. So this is another important formula, very useful. Usually found in electromagnetic theory, where we deals with Maxwell's equations. Usually for del dot E and del dot B. Now let us see different formulas. First one starting with the divergent of r power n into n r cap. Okay. R cap. So before doing that, let us write down the formula. The del dot f of r into r cap is equal to 1 by r square dou by dou r of r square f of r. Okay. So substitute, so 1 by r square dou by dou r of r square, and what is the f of r here? It is r power n. So r power n is the f of r. So this becomes 1 by r square dou by dou r of r square into r power n. So that is equal to r power n plus 2. So that's again equal to 1 by r square dou by dou r of r power n plus 2, that is n plus 2 into r power n plus 1. So again this is r power n plus 1 divided by r square, that is r power n minus 1. So n plus 2 into r power n minus 1. So this is the divergent of the function r power n into r cap. Similarly, you can write for del dot r into r cap, that's equal to r power this is del dot r, that is equal to 3, because just substitute here n equal to 1 in this equation. Just substitute del dot r to the power 1 r cap. So that will be equal to n plus 1, that is 1 plus 2 into r power n minus 1. So n is 1 minus 1 0, so that's equal to 3. So del dot r or del dot r into r cap is equal to 3. So third one, del dot r square r cap is equal to 4 times the r. Then you have del dot r power minus 1 r, that's equal to 1 divided by r squared. Now fifth one, that's important, del dot r power minus 2 r cap, this is equal to 4 pi into delta cube of r, which means this function del dot r to the power n r cap, n plus 2 into r to the power n minus 1 is valid only when n not equal to 2. N only for n not equal to, sorry, not equal to minus 2. Okay, only when n is not equal to minus 2. When n equal to minus 2, this is the formula. Okay, this is Dirac function. Curl of a radial vector. In general, the vector del cross A is written as 1 by h1, h2, h3 times h1 q1 cap, this h2 q2 cap, h3 q3 cap, dou by dou q1, dou by dou q2, dou by dou q3, and here you have h1 times a1, h2 a2, h3 a3. So this is the curl of the vector A. Now if we need to write the function, the curl of the radial vector, which means the function A is equal to AR, or only here you get. So here what you can get is the other terms, like let us write down that, we will understand then. 1 by this h1 h2 h3 is r square sine theta, h1 r cap, this is r theta cap, r sine theta, phi cap, dou by dou r, dou by dou theta, dou by dou phi, this is AR, this is A theta into, this is R times A theta, this is R sine theta times A phi. Now for a radial vector you do not have this A theta terms and the A phi terms, which is A theta, and there will be no A theta and A phi terms. Okay, so A theta and A phi term is 0, so these two quantities will become 0, which means the radial vector or the del cross A will be equal to 0, because the curl of a radial vector means it goes outwards, outward normal, its curl is 0. That is why the this is del cross A, del cross of E is equal to 0, because E is a radial vector, it is going perpendicular. Okay. Now from the concept, that is the curl of f of r is any radial vector, is equal to 0. So this is the idea that if del cross f of r, so f of r is a radial vector, so del cross f of r will be equal to 0. Now we also know that del cross the gradient of some function phi is also equal to 0. So here we have the equation 1, this is equation 2, and from these two equations we can write f of r cap is equal to the gradient of some function phi. So f of r can be written as some gradient of some function phi. Now since del cross f of r equal to 0, this concludes that the function f of r into r cap is irrotational, which means it diverges from a point. That is why it does not curl. So it is moving, diverging away from a point. If it was curling around, this is an electric field, this is the magnetic field. If you curl around, that is magnetic field. So del is an example of electric field which diverges. So f of r can be taken as an electric field, so it is irrotational, that means it diverges, irrotational, diverges, it does not curl. We can also write does not curl. Curl means winds up, winding up. Okay, so if we have a function f of r which is irrotational, then so let us write down that in words. For every irrotational conservative field f, there exists a scalar such that f is equal to del phi. Now what is this conservative? Conservative field means the work done. Conservative meaning work done in this field do not depend on the path. Examples of V potential, electrostatic potential, potential field. Similarly, we also have the gravitational potential, and also in thermodynamics pressure versus volume, PV graph, all are called conservative field, and they are also called point functions. This is due to because the work done depends only on the initial and final points in the graph, initial and the final points. It does not depend on the how you go. You can go from like this or like this, but uh, whichever path you follow, it depends only on the end points. Okay. Question: f is given to be y square minus x square plus y I cap and x into 2y plus 1 j cap. So this is the vector, this is plus. Okay. Now find phi if f is irrotational. So if f is irrotational, what you can write? Del cross f equal to 0, right? So f is already given, so f is equal to del phi. Now you need to find out phi such that f becomes irrotational. Now what is f is equal to del phi means? Del phi is equal to x cap dou by dou x of phi, we don't know, plus y cap dou by dou y of phi plus z cap dou by dou z of phi. So for each term you will get one value of phi, correct? So let us take the first term, dou by dou x of phi. So f can be written as, this is equal to fx, fy, fz, different components of f. So dou by dou x of phi is equal to, so this is with respect to x, so x cap, what is the term? Y square minus x square plus y, right? So then phi will be equal to integral y square minus x square plus y with respect to x. So that becomes xy square minus x cube by 3 plus xy. So this is the first term fx. Okay. So but phi should not be different, we have to write phi in single term. So now next use the second term, dou by dou y of phi. So dou by dou y of phi is equal to this, let us write 2xy plus x. So 2xy plus x, which implies phi is equal to integral 2xy plus x with respect to y. So 2xy square by 2 plus x xy. So this is 2 to get cancelled. So x square y plus xy. Now with respect to z, dou by dou z of phi is equal to 0, which means phi is equal to constant. I am writing it as constant itself. So I need to add 1, 2, 3 because this is partial derivative. So phi will be equal to sum of this, but I need to remember which is already present there, I need not write. So xy square, this is xy square here, in the first term, and xy square is already existing, so I need not write it 2 times. So x y square once minus x cube by 3 no terms plus xy, but here there is another term, but I wrote only once, that's fine. Another term, there is one constant plus one constancy, so phi is equal to this much. So f is equal to 3x square y square z power 4 I cap, and we need to find phi. So del phi can be written as f. So what is del phi? That's equal to I cap dou by dou x of phi plus j cap dou by dou y of phi plus ij, let us write k dou by dou y of z of phi. Now let us take the first term here, dou by dou x of phi. So dou by dou x of phi is this. So dou by dou x of phi is equal to 3x square y square z power 4. Now which means phi is equal to, integrate this, so that will be equal to 3x cube by 3 y square z power 4. So that's equal to x cube y square z to the power 4. Similarly, dou by dou y of phi is equal to this is the second term, so 2x cube y z power 4. So integrate, which means phi is equal to 2x cube y square by 2 z to the power 4. So that's equal to 2 gets cancelled, x cube y square z to the power 4. Now the third term, dou by dou z of phi is equal to 4x cube y square z cube, which means phi is equal to, integrate this, so 4x cube y square z to the power 4 by 4. So that's equal to x cube y square z to the power 4. So this is the first term, second term, third term, but all these three terms are same. So we will write phi is equal to x cube y square z to the power 4 plus some constancy. Here is a question for practice. F is equal to e to the power xy times yi plus xj plus 2e to the power z times k. Find phi such that del cross del phi is equal to 0, which means del phi is irrotational. So if it is irrotational, you can find phi.